Welcome back to the introductory series of videos concerned with orthographic drawing. We're going to be building from the short demonstration where we sliced up a capsicum, and we're going to look at a more regular constructed object. In this case we have a cube that's constructed with various sticks, and the sticks are combined in different configurations. These cubes will form part of the first series of foundational workshops, so we're trying to sort of align the explanation of the orthographic drawing with the exercise that you will be completing. You can see the three-dimensional representation of the cube, or simple photograph. We can see the top, front and side of the cube. If we were to make a drawing of this, so we could give it to another builder or fabricator to replicate a similar object, we would need to give them a little bit more precise information and drawings that they can accurately work from. Simply working from a image that doesn't have any scale or true length is not very useful. Here we can see the top, front and side view of the cube, and we're going to work through these three elevational views of the cube in the first instance, starting with the top. Now, looking straight down on the top view of the cube, we can start to see the different layers of the sticks that we can see through the middle of the cube. It starts to get a little bit more abstract, the view of it. And you can see when we translate that to a measured drawing with straight lines and right angles, it does become a little bit more difficult to read. Now, we have added a little bit of colour into this to help register the different layers, but in proper orthographic drawings you wouldn't typically do this. What we can also do to give a little bit more detail and help read between drawings, because we don't just draw one or two views, we do tend to draw many views together, and the way you read between the orthographic drawing gives you a full three-dimensional understanding of the object. Here we're adding some hidden detail lines. Now again, this makes it look a little bit cryptic, but we can begin to see the corner posts shown in the hidden detail on the four corners, and the two elements going through all the way through to the other side. Now, looking at the front view, similar sorts of procedures are followed. There we can see an approximate view taken as a photograph, and here we can see it's almost like a robot face view. A very simple straight line measured drawing where there is no perspective, it's absolutely flat. Again, we can add in the hidden detail line to help give us some idea of what's behind the front surface of that drawing, and when we start relating that to other faces, then we can get a better understanding of the three-dimensionality of it. We've also got the side view here, and again, same deal. We can see a little bit more information with the hidden detail. The hidden detail line is a dash line, where the dash and the space are more or less equidistant. You would show the hidden detail line in a plan and a section, possibly an elevation in this instance, and you would only show what's immediately hidden in the first layer. You wouldn't show each layer behind that as well. Otherwise, each layer the whole drawing will become very difficult to understand. In this instance, the sectional view is actually going to help us quite a bit, particularly when you read this in relation to the other views. A sectional view is a perpendicular cut through the object. We haven't actually literally sawn it up, but we can interpolate from measuring the cube what that section will look like. So we're going to cut more or less through the center of the cube as shown, and we're going to look towards the part of the cube where the arrows are pointing. So when you see the section cut through here, we can begin to see the different elements. We can see the four sides of the cube, this element here which is cut through, and this element through the middle, which is looking at one of those elements running through at the top, but it's looking at it in elevation. We can add some hidden detail line again to make that a little clearer. The plan view, again similar to the section view, but it's in parallel to the ground plane and typically looking down onto the cut object. Here we're cutting it pretty much through the center of the cube. Again, you can see the four corner posts of the cube and the one element that's running along the bottom there. To make it clearer that that element is sitting on top of the perimeter elements, we can add a hidden detail line to sort of indicate that. In plan, we also add a different type of line, which is called an overhead detail line, which shows the objects that are hovering above the cut line, and in this case we pick up the two elements that are above it, and these are shown with a dot dash line. Just to reiterate, a hidden detail line is a dash line of reasonably equal spacing. A dot dash line is overhead detail line. A solid line shows the outline or profile or elevation of an object, and a dark solid line will usually show a cut through an element. It's important to note that you never overlay the three different line types. You would only see a dash line where there isn't a solid line, and a dot dash line is, I guess, the last in the hierarchy. You would only see a dot dash line assuming there wasn't a solid line or a hidden detail line in the same plane. The explanation here of the orthographic and the drawings themselves do look a little bit confusing on the first viewing. It's important to, I guess, do the workshop exercises and to sort of review the video in context with that, and working between the two. And by actually doing the exercise, you will get a much clearer and almost intuitive understanding of the conventions of orthographic drawing.